Our unfathomable lead is way out of this world, 390 light-years away. Truth be told, for setting 1 light-year is unclear at 6 trillion miles in humanity's resolved excursion for relaxing the insider-privileged insights of the universe. We've set out on a mission that goes beyond time itself, looking for replies to progress in years-old solicitations woven into the outer layer of existence. The James Webb Space Telescope, with its unblinking eye, has actually perceived a short look at a design beginning before the show of stars. This great thing transmitted an impression of being more ancient than the actual universe, raising a greater number of questions than it answers. How could an arrangement exist that originates before our universe? Or is the speculation of how things came to fault? Join us as we set out on an odyssey coordinated by the discoveries of the James Webb Telescope to unravel the mysteries of a 13.8 billion-year-old development. The journey to relax these tremendous secrets has scarcely begun. In a far-off corner of the universe, around 200 light-years away, an old star called HD 114283 lives near the Libra star grouping. This famous traveler moves excitedly through space, offering fascinating brief glimpses into its savage past. Unequivocally 12 billion years ago, when our Milky Way was still in its beginning stages, it ingested a dwarf galaxy that once called it home. Be that as it may, what truly piques our infinite curiosity in HD 114283 isn't simply its quick cycle, it's its astonishing age. Among the heavenly objects we've seen, it remains one of the oldest, earning the captivating moniker Methuselah star, contrasted with the scriptural figure Methuselah, who legend has it lived for a considerable length of time. Initially assessed to be a stunning 16 billion years old, the most recent evaluations propose a fairly more youthful age of 14.46 billion years, with an edge for mistake of 0.8 billion years. This discovery about its age perplexed space experts. After all, the age of the universe, as determined from the astronomical microwave background, floats around 13.8 billion years. This issue raised enormous questions about the star's age, the universe's age, and, even more crucially, the exactness of our dating strategies. We should break it down. Sorting out the period of divine objects can be a real riddle. Take stars, for example, like the sun. They're similar to godlike lights, maintaining their brilliance, temperature, and size for billions of years, making them interesting to age date. Cosmologists use changes in brightness and color as hints, coordinating these with models predicting how stars develop over time. One age giveaway is the speed at which a star turns, like a wheel. Stars slow down over time, and by looking at the rotational paces of stars at various ages, stargazers have worked out a smart trick called gyrochronology. Stars also spill their age insider secrets through magnetic chatter, flares, and discharges of energy on their surfaces. These vigorous signals give space specialists a way to listen in on heavenly discussions. With cutting-edge methods like astroseismology, they tune in for vibrations caused by waves traveling through a star's interior. These vibrations can reveal a star's age. For example, applying this method to the sun, space experts decided its age to be 4.58 billion years. Now, back to Methuselah star. The old transmission around it isn't just conflicting. Stargazers classified it with an advanced age by looking at its vast beginning. Stars can be arranged into groups based on how much bling or heavy elements like iron they have. Our sun is a metalhead, belonging to population 1 stars, while Methuselah star, on the other hand, resembles an old artifact from population 2, with fewer heavy elements. It's the divine wink-out that assists cosmologists in playing astronomical archaeologists, disentangling the age accounts of these magnificent animals. Now imagine a group of stars, hypothetical population 3, which cosmologists suspect may be the universe's most ancient pearls. However, they're still hiding behind the scenes and haven't yet appeared in our telescope spotlight. Space specialists suspect these stars may be the legends of creation, containing practically no heavy elements. To get a handle on the cosmic arrangement, we need to rewind to the universe's early days, just after the Big Bang. Picture a perpetual kitchen filled for the most part with hydrogen and helium, the universe's primary fixings, around 92% hydrogen and 8% helium, or if you average it, around 75% hydrogen and 25% helium. In this grandiose outfit, the first entertainers on stage were the population 3 stars. They were enormous and hot, consuming their fuel quickly, changing hydrogen and helium into heavier elements. When these early cosmic beasts detonated, they spread these heavy components into the immense range. Next came the population 2 stars, forming a late but still important chapter in mankind's early days. Their original materials were stacked down with heavy components, especially iron. Many of them went through their heavenly life cycles, impacting into supernovae and adding more heavy components to the all-encompassing mix. Finally, the population 1 stars, including our Sun, arose as big beginners, forming from cutting-edge gas clouds blending in with leftovers from the prior population 2 stars. Now the central question. Does the tremendous story toss an endless bend at the theory of the old Big Bang? It's a head-scratcher. However, here's the twist. There's a 70% chance that Methuselah's star, the old divine wanderer, could be roughly 13.66 billion years old. There's a 15% chance its age is playing outside the cosmic rulebook. Besides, there's a 15% chance it's not as old, perhaps significantly younger. Imagine rolling a standard 6-sided die and expecting a specific outcome, notwithstanding what these vast twists throw at us. One thing is certain. Methuselah's star isn't simply an enormous veteran. It's the granddaddy of stars. We sorted out how to give it an age name that is darn accurate. Now, here's where it gets wonderful. Rather than scratching our heads about where Methuselah's star could be 2 or 3 billion years older than its enormous neighbors, how about we flip the cosmic content? Consider the possibility that the universe itself isn't as youthful as we once suspected. We've been trying to make sense of the vastness of space, and if we turn the whole history of the universe into an inestimable schedule with the Big Bang as the most extraordinary New Year's fireworks, Earth wouldn't join the Big Mallet until as late as December 31st human recorded history. That's only a blip in time, covering just the last 10 seconds. Our galactic analysts determine the universe's age by looking at old starlight from a few hundred million years after the Big Bang. As the universe expands, it gives this light a giant makeover known as redshift. By crunching the numbers on both distance and expansion, experts pronounced a general age of 13.8 billion years. But hang on, the Big Bang situation is going to get interesting. A study from the University of Ottawa suggests the universe may be an incredible 26.7 billion years old. Professor Rinder Gupta picks up on a charming hypothesis from 1929 made by Swiss cosmologist Fritz Zwicky, and it's shaking up our infinite understanding. This theory proposes that as light particles, photons, travel through the limitlessness of space over time, they lose some of their energy. This idea doesn't perfectly align with what we've seen through our telescopes. Gupta proposes an infinite compromise. He suggests we can mix this hypothesis with our current understanding of an expanding universe, creating a hybrid explanation for the redshift phenomenon. Now, locking in changing the universe's age to a mind-boggling 26.7 billion years is no small feat. Gupta adds another twist to the cosmic blend by combining the light loss hypothesis with evolving coupling constants, a brainchild of theoretical physicist Paul Dirac. This idea suggests that the way particles interact may have changed over time. And hey, researchers have a history of tweaking the astronomical clock. Back in the 1920s, Edwin Hubble thought the universe was only a simple 2 billion years old. We've come a long way since then, refining our galactic math and expanding the universe's age like bringing a giant leap into our tremendous viewing. Anyway, whether this new viewpoint becomes the cosmic norm is still up in the stars. Whether human history is a simple blip of 10 or 5 seconds in the grand plan of the universe, one thing is certain. The universe is a treasure trove of old supernatural occurrences and endless motivation. Looking to our huge lawn, the Milky Way, there's a staggering, tremendous tango occurring in the universe. Ongoing appraisals hint that stars on the edges of our universe are swaggering their stuff in slow motion compared to their companions in other galaxies. What's the COSM scoop? Well, there are a couple of theories, and one hypothesis is that our Milky Way may be running almost out of an undetectable, gigantic fixing called dark matter. This subtle substance impacts the gravitational dance of galactic objects. There's a heavenly secret involving dark matter, the baffling substance we can't see but appears to play a gravitational role in the universe. One chance that is shaking our tremendous comprehension is that maybe we've been assessing dark matter wrong. Our universal compass may point off kilter. Here's where the European Space Agency's Gaia satellite steps into the infinite spotlight. is like our galactic inspector, giving complex insights into the dance of nearly 2 billion stars in our Milky Way. Consider it a massive improvement test. The satellite's exact measurements have led cosmologists to re-examine their galactic notes. Stars at the outer edges of our Milky Way seem to be moving slower, challenging our old assumptions about their speeds. How truly do star speeds spill the cosmic beans about a universe's mass? It's like checking the size of a party by how rapidly people are moving. Armed with Gaia's information, space experts assess the total mass of our galaxy's gas, dust, stars, and that slippery dark matter to be around 200 billion times the mass of our sun. It seems like a galactic heavyweight, but here's the twist. It's only about 1/10 of what we previously thought. One theory to settle this galactic riddle suggests we might have been entirely too massive with our dark matter estimates. Maybe there's less dark matter out there than we once thought. Anyway, hang on. Measuring a universe is like attempting the unthinkable. The data could have a few quirks, or our astronomical measuring tape could need some adjustments. On the other hand, other research groups have joined the infinite assessment, and they all seem to be murmuring the same universal tune. If this extraordinary discovery holds, it's like opening a new chapter in our giant physics course. A twist that could make us reconsider not just our own Milky Way, but every gleaming corner of the universe. As Stacy McCarr, a space master at Case Western Reserve University, puts it, this could be an astronomical game-changer. Returning to the 1970s, when space expert Vera Rubin and her huge team set out on a divine mission, their goal was to study how stars moved in different galaxies. The old playbook suggested that stars on the edges of a galaxy should be slow movers compared to the zippy stars nearer to the center. It's like how Neptune takes its time circling the sun, while Mercury is the eternal speedster. However, what Rubin and her team found was a grandiose shock. Stars at the far reaches of galaxies were moving at almost the same speed as those nearer to the cosmic dance floor. Imagine a giant disco where everybody, regardless of where they are, is moving to the same beat. This tremendous discovery suggests the presence of something complex and invisible, dark matter, the inconspicuous heavyweight champion that forms immense halos around galaxies. Ponder early space specialists like Copernicus and Kepler. We've come such a long way since then, but we're still the freshmen, wide-eyed at the cosmic wonders, trying to unravel the universe's mysteries. Our Earth is like a little island in the tremendous expanse of space, twirling around the sun, surrounded by stars in our little galaxy. Our mission for meaning among the stars is at the core of scientific investigation, even when answers shock us. This curiosity keeps us traveling further into the universe. It's an endless venture, where every answer brings new questions, ensuring our astounding exploration never stops. The universe continues to amaze us with its vastness and intricacy. Every discovery takes us deeper into the complicated web of cosmic history, revealing the crucial principles that govern our reality. Continuous research has shown that galaxies aren't isolated entities, but are interconnected through a complex web of dark matter and gravitational forces. This understanding leads us to rethink our models of universe development and evolution. One of the most interesting parts of galactic research is the concept of gravitational waves, ripples in spacetime caused by some of the most extreme events known to humanity, like merging black holes or neutron stars. Originally identified in 2015, these waves offer a new way of observing the universe, providing insights that conventional telescopes could miss. They open a window into phenomena that are invisible to electromagnetic radiation, allowing cosmologists to study events from the early universe and improve our understanding of the fundamental forces at play. Furthermore, scientists are also studying exoplanets, planets orbiting stars outside our solar system. The discovery of potentially habitable worlds raises important questions about the possibility of life beyond Earth. Methods like transit photometry and radial velocity measurements help identify these distant planets, unveiling other planetary systems that challenge our assumptions of how planetary systems should form. Some of these exoplanets lie in their star's habitable zone, where conditions may be ideal for liquid water, a key ingredient for life as we know it. As we probe further into the universe, the role of artificial intelligence in analyzing vast amounts of data becomes increasingly critical. AI algorithms can detect patterns and anomalies in celestial light curves, leading to the discovery of new heavenly bodies and phenomena at a pace once thought impossible. This collaboration between human intuition and AI is propelling us into an era of extraordinary galactic discovery. As we continue our cosmic exploration, we must acknowledge the role of quantum mechanics in shaping our understanding of the universe's smallest scales. Quantum physics, with its paradoxes and uncertainties, underpins the behavior of particles in ways that classical physics cannot explain. It's through quantum mechanics that we begin to understand phenomena like black hole evaporation or Hawking radiation proposed by Stephen Hawking. This theory suggests that black holes, once thought to be inescapable, can actually emit radiation and lose mass over time, eventually evaporating completely. This discovery challenges our conventional views of black holes and introduces profound implications for the nature of space and time. Moreover, as our technological capabilities improve, we're now able to detect and study distant galaxies in unprecedented detail. Using tools like the Very Large Telescope, VLT, and the upcoming Extremely Large Telescope, ELT, astronomers can peer into the distant past, capturing light that has traveled billions of years to reach us. This enables us to study galaxies as they were in the early universe, offering clues about galaxy formation, evolution, and the role of dark matter in structuring the cosmos. At the same time, efforts to understand the nature of dark energy, responsible for the accelerated expansion of the universe, continue to make strides. Whether through supernova observations, galaxy surveys, or cosmic microwave background measurements, we are gradually unveiling the mysteries of these unseen forces that dominate the universe.